Now in question 8, this is a experimental setup for us to determine the specific latent heat of fusion of a material, in this case ice. So what we have here is a heater actually supplying energy to ice. So the amount of energy that is supplied can be calculated from the joule meters, and you can figure out how much ice has melted over here, and that's how you can calculate out the specific latent heat of ice. Now, a control experiment is important in such experiment, because even without the heater, the ice will melt, right? Because the surrounding is warmer. So uh, we do not actually know how much energy is absorbed by the ice from the surroundings. So we would want a control setup to tell us how much water has melted purely because of the environmental heat that was absorbed by the ice and not from the heater. So that's why the purpose of the control apparatus is to determine the actual mass of water melted uh, by the environment alone. And then uh, when you have the mass of the water melted during the experiment because of the heater, you can then subtract these two values to figure out the actual mass of water that melts purely because of the heat supply by the heater only. Why should the ice be crushed and melting? Now, um, we always use crushed ice in thermal experiment because we want there to be want it to have very good contact with the heater. A very big ice cube. If you use very big ice cube, then the ice cube, you will have a lot of gaps in between, and there will not be very good contact with the heater. Now, the reason why we use melting ice is because, as you know, when we see a mixture of solid ice and liquid water, we know for sure that the temperature will be kept constant at 0 degrees Celsius, as if the water is pure. So we want this to be the case. We want the starting temperature to be at 0 degrees Celsius. In this part, you are to calculate the specific latent heat of fusion of the ice. So first step, do a simple subtraction to figure out the amount of ice that melts purely because of the heater alone, and not because of the environmental heat that it has absorbed from the surroundings. So the simple subtraction should get you 0.036 kilogram. Next, figure out what is the amount of energy provided to melt this ice. So use subtraction again between the two joule meter readings to get you 14,200 joules of energy supplied. So use the latent heat equation where Q equals to LF equals to M times small LF, and plug in the values accordingly. You will be able to calculate the specific latent heat of fusion of the ice. Part D is a thinking question. So, uh, what happens to your results if, number one, you do not use a control experiment? If that is the case, then the amount of mass that melts, the amount of mass of ice that melts that you recorded down will be an overestimate. It will be higher than usual because the amount of mass, without doing the subtraction, the amount of mass will be the ice that melts because of the heater and also because of the environmental effects. So, uh, the with a similar amount of energy supplied to melt the ice from the joule meter, you are using it to melt a bigger value of mass, which is an overestimate. So end up you will have you will under report you will have a smaller calculated value of latent heat and specific latent heat of fusion. Now for part two, what happens if you don't use ice at 0 degrees Celsius? You use ice that starts at -3 degree Celsius. Then if you start with negative 3 degrees Celsius ice, then you need a lot more energy from the heater to raise the temperature of the ice from negative 3 degrees Celsius to 0 degrees Celsius before it even starts melting. So the amount of energy that you record from the joule meters will be a bigger value, overestimate. So the bigger value of energy uh, reported from the joule meter will then make your calculated value of latent heat and specific latent heat to be much higher, which is an overestimate of the true value.